You may have heard of stoichiometry. It's basically the relationship between a chemical reaction and the chemical equation that describes it. But what about limiting reactants? For any reaction, the limiting reactant is the reactant that limits the amount of product that is possible to form. Or in other words, the reactant that decides when a reaction stops. To visualize this, it's good to differentiate between the chemical equation and the actual reaction. Imagine these two as the recipe book and your actual cooking process. Supposedly, you want to make 5 sandwiches for breakfast. Looking at the recipe here, you need 1 meat and 2 slices of bread to make only 1 sandwich. And you only got 4 slices of bread and 5 meats. How many sandwiches can you make? Let's craft it to find out. You can only make at most 2 sandwiches, since we have 1 meat left that is considered as our excess reactant, whereas the bread, it is considered as our limiting reactant, because it limits the number of sandwiches we can make. This cooking talk is all good, but let's find a more chemistry-like example. Take the combustion reaction for rocket launching. The reaction can be written like this, and supposedly we have 6 moles of oxygen gas and 4 moles of hydrogen gas. Which one do you think is the limiting reactant? Now, quite unfair of me to ask this question without teaching you anything. Simply, there are 3 methods of calculations to determine which is the limiting reactant. But for the sake of this video, we will only cover one method. For this method, it's simple. Mole over coefficient. Mole referring to how many moles we have, and coefficient from the balanced chemical equation. For oxygen, we have 6 moles, and referring to the chemical equation, the coefficient is 1. Solving that will get us to the ratio of 6. Doing the same for hydrogen, and we get the final answer of 2. To know which one is limiting, we will take the smallest ratio, and in this case, the hydrogen. Now, this is way too straightforward, so here's another example. With 5 grams of magnesium and 25 milliliters of 0.02 molar of hydrochloric acid. We use the same formula, but remember it needs to be in mole, but the info we have are not in moles. We simply convert the mass to mole by multiplying molar mass and use the N equals to mv formula for the acid, plugging in the moles value, and we get our final answer. We've been discussing the how to identify the limiting reactant, but what about the why? Why do we even bother to know about such things? It's because by knowing the limiting reactant, we can accurately predict the amount of products formed. The ability to know how much product a reaction will make is essential in many fields. To finding the right amount of guanidine nitrate in airbags, for them to inflate fast enough, as well as avoiding excessive amount of carbon dioxide formed by dialysis machines that would enter the patient's blood. But putting that aside, why only limiting reactants? Returning back to our kitchen, the picture gets clearer. If we look back at the recipe, how many we have, and if we were to predict the amount of sandwiches that we can make from the number of meats, which is excess, we would get 5 sandwiches, which we know is impossible. As of now, it seems like limiting reactants are something that would run out completely by the end of the reaction, but that is rarely the case. In reality, most reactions would still have some limiting reactant unreacted, because real-world physics is much more complicated, and that also means that the actual product we get is lower than the calculated ones. This difference between the actual amount of product is what we call as percentage yield. For the formula, it's basically the mass of the actual product over the mass of the theoretical one times 100%.
Vinegar will be the excess, while baking soda will be the limiting reactant. This is our first time experiment. Let's give it a try! we give it a second try. Let's give it a go. Okay guys, this is our one and last chance. So let's give it another try. Okay.
Wish.